Hi, this video is going to go over questions 8 through 10 from the quiz for Module 3. These are the ones that dealt with the cumulative distribution function. So here's the question, and remember that the cumulative distribution function, capital F of W, is the probability that the random variable W takes on a value less than or equal to a particular value, little w. It's defined for all real numbers from negative infinity up to infinity. So even though the random variable W may only take on a discrete number of possible values, this this cumulative distribution function is going to be defined for all real numbers. So for instance, the fact that the probability that W takes on a value less than little w for all values less than -1 is 0. What that means really is that W cannot take any value less than -1, because the probability that W is less than -2 is 0. The probability that W is less than or equal to -1.5 is 0. It's got to be at least -1. So this is what this is telling us. Now we can see that at -1, the cumulative distribution function jumps up from 0 to 0.75. So the probability that W is less than or equal to -1 is equal to the probability that W is less than -1 plus the probability that W is equal to -1, because it can't be both less than -1 and equal to -1. So the probability that W is less than or equal to is -1 is 0.75. This has to be equal to the probability that W is less than -1, which we're given in the cumulative distribution function is 0, plus the probability that W is equal to -1. So what this tells us is that the probability that the random variable W takes on the value -1 is 0.75. Now, using this logic, we can find the probability mass function for the random variable W. The next possible place that the cumulative distribution function increases is at 1. So that's going to be the next possible value that W can take on. Using the same logic, we can see that f of 1, the probability that the random variable W takes on a value less than or equal to 1, is the probability that W is less than 1, plus the probability that W is equal to 1. The probability that W is less than or equal to 1 is 0.99. The probability that W is less than 1 is 0.75. Which means that the probability that W equals 1 is going to be the size of that jump. It's going to be the distance between 0.99 and 0.75, which gives us that the probability that W equals 1 is 0.24. So following the same logic, we can create the probability mass function for W. And we could stop the video for a minute and try to do that, and then you can check your work in a minute. Okay, so this is our probability mass function for W given in the table here. You can see that the probability that W takes on a value corresponds to the size of the increase in the cumulative distribution function, how much more probability there is that a value takes on, that the random variable takes on a value less than or equal to that particular value. And so places where the cumulative distribution function remains constant, those are the values that there's no probability, no positive probability associated with. Okay, so now coming back to answer questions 8, 9, and 10. What is the probability that W is equal to 1? The probability that W equals 1 is 0.24. What is the probability that W equals 5? Well, 5 is one of the places in between the jump points in our cumulative distribution function, which means that the probability that W equals 5 is 0. It's not one of the possible values. And then our last question, let me see if I can pull us up enough to keep it all on one page. What's the probability that W is more than 10? Probability that W is greater than 10. that's going to be 1 minus the probability that W is less than or equal to 10. Still do less than or equal to 10. Which is 1 minus point. Looking at my cumulative distribution function, 1 minus 0.999, which is 0.001. Or I could have just looked at my probability mass function and seen that the probability that W is greater than 10 is equal to probability that W equals 100, which is 0.001. But either way, I get the same answer. I hope this is helpful in helping you work through the cumulative distribution function problems. Thanks.